Hi students, welcome to my lectures on mechanical unit operations. Today we are going to discuss about the particle shape. It has got many applications in the area of chemical engineering where it would be interest of finding the surface area of the particles, number of particles in a mixture, and the other benefits of so in finding the shape. Typically, if you talk about the shape of the particle, the best possible equidimensional shape we can assume is a sphere, a ball. It is dimensions are equal in all the directions. So simple, if you wanted to tell what is the shape of a sphere, simple diameter, mentioning its diameter is sufficient. When you talk about the square, the length of the square, length of the one side of a square is sufficient to mention what is the shape and size of a square. Imagine the particle which is of very random shape. Okay, you can see, you can see cylindrical in nature. As I'm showing you, the marker. Initially, it has some cylindrical in nature. Later on, it has got some cap. So if you have to define what is the shape of this marker, I need to find a different means of defining it. So in mechanical unit operations, to define a shape, a term which people normally use is called sphericity. Always, because the sphericity means always we are comparing the shape of this marker with that of a sphere. If this shape of this marker would have been round, then the sphericity of this marker is 1, because when you compare the round marker with that of a ball, the ratio of this ball, sphere divided this ratio of this marker which is of a ball, 1. That means the more spherical the nature of the particle, the sphericity is close to 1. So we go into deeper into the definitions of this particle shape. If you observe here on the board, here you see a circle is drawn. Here a square is represented. The shape of this circle is close to the, if I take the 3D dimensions of this particular circle, it will be of a sphere. You can easily define what is this shape. It's a square shape. Can you tell me what is the shape of this random particle? Because as you go smaller materials, because normally as an engineer you have to deal with the nanomaterials or micron shape, micron sized materials. As you go down to the smaller dimensions, the shape will be varied. It is not simple to define what is the shape. For example, whatever I have shown on the board, the shape here is defined very random shape. It is not even close to the of a sphere, not even close to the of a the square. So somehow, if some people ask me what is the shape, then I have to define some definition. That is the definition which is called sphericity. According to the definition of sphericity, which is represented with phi, which is nothing but surface to volume ratio of sphere of diameter dp divided by surface to volume ratio of the particle. If you somehow measure this ratio, then you can get a sphericity, a number. If it is 1, that means the particle shape is spherical in nature. If it is much less than 1, that means the particle is not spherical in nature. It is as the random shape is the particle, the sphericity will be very, very less. That is why you can see there are no units for the sphericity, because in the numerator it is the surface to volume, denominator is also called surface to volume. The units gets cancels out, and this sphericity is a dimensionless number. The numerator, surface to volume ratio of the sphere dp. We are comparing with it of a sphere volume divided by particle volume, in which I am interested to measure its shape. Surface to volume ratio of random sphere divided by surface to volume of the particle whose nominal size is dp. And it is a bit tricky to understand the nominal or equivalent shape. So nominal shape and equivalent shape, both are same, don't get confused. And here if you see the sphericity, according to the definition, surface to volume ratio of particle, sphere of particle volume divided by surface to volume ratio of the particle. What is the surface to, if I take a sphere, what is the surface area of the sphere? Which is pi dp square. What is the sphere volume? 16 pi dp cube. That is nothing but sp by vp of a spherical particle divided by sp by vp of the particle which I am interested to calculate its shape. From this definition, I got phi equal to 6 by dp by vp by sp. Okay. And what I am actually measuring, pictorially I am representing this way. Sphericity is nothing but numerator we are comparing with that of a sphere, denominator a random particle, which is what the definition of the sphericity. We are comparing surface to volume ratio of the sphere divided by surface to volume of random shaped particle. In order to define the sphere, which random sphere we are going to take. Suppose I know if I take a particle, I know this is pen, I know its surface area, I know its volume. Okay, I can able to get the denominator which is by Vp Sp. Then what is dp? It's a diameter of a random imaginary sphere. And we need to find out with what sphere we have to compare with the random particle. That is what the equivalent diameter concept. Let us go ahead and let us see through one example that how to find out the sphericity and equivalent diameter dp. Students, in continuation to the sphericity, we are going to solve one example of how to find equivalent diameter. From the equivalent diameter, how to get the sphericity. And you need require three things. One is surface area of the particle, volume of the particle, and three, equivalent diameter of the particle. What is this equivalent diameter concept? Because in the definition we have to compare with that of a random sphere. What is this random sphere? If you could able to define what is the random sphere, from this random sphere we get a diameter that is nothing but equivalent or nominal diameter. Okay, let us go ahead. Imagine this is the random shape of the particle you wish to measure the sphericity. Okay, let us, it will occupy some volume, right? Any particle will have some volume. Construct the volume, a sphere of same volume of the particle. Example, if the particle is 3 centimeter cube, example, volume, construct the 3 centimeter cube volume of a sphere, which is of equal volume of that of a particle. So, the volume of the sphere of 3 centimeter cube, okay, you have formed, the diameter of this 3 centimeter cube of this random or imaginary sphere is nothing but the equivalent diameter of this particle. Okay. Construct this random sphere of same volume as that of a particle, equate the volumes. This is an irregular particle. Irregular particle volume is equal to imaginary sphere volume. Once you equate these two volumes, you get one diameter. That diameter is nothing but the nominal or equivalent diameter. Example, imaginary particle volume of random shape, example, koi bhi random shape, is equal to 3 centimeter cube. Find the nominal diameter. Simple. Volume of this particle, random shape particle, is 3, is nothing but equal to volume of the imaginary sphere, 16 pi dp cube. From this equation, whatever the diameter you get, a number you will get some number, that number is nothing but the equivalent diameter of the sphere. Once you have this equivalent diameter of any particle, okay, you can compute the sphericity. Let us compute the sphericity of a spherical cube, cube. Example 2, find the sphericity of a cube of size A by A by A. That means if I construct a cube, each side of a cube is of length A by A by A. Now our question is to find out the sphericity of this particular cube. So sphericity definition, phi of cube is nothing but 6 by dp Vp by Sp. dp is the equivalent diameter of this particular cube. That means if you construct a sphere of same volume as that of a cube, whatever the diameter you get for that random imaginary sphere, that is nothing but the equivalent diameter dp. Vp is the volume of this cube, Sp is the surface area of this cube. Let us see what is the volume of the cube. Length into breadth into height. Example, length A, breadth A, height A, which is A into A into A is equal to A cube. What is the surface area of the sphere? How many sides a cube have? 6 sides. Every side, what is the area of the cube? A by A. So if area of the cube is A by A of one side, the total surface area of the cube is 6 times this one area. That means 6 times A into A, that is 6A square. Now let us find the equivalent diameter, because once you know Vp, Sp and dp, you put it in the formula, compute the sphericity. What is our trick? Equate the volume. Volume of the cube, the random particle example, the volume of the cube is equal to volume of the imaginary sphere of diameter dp, just like we have done in the previous example. What is the volume of the cube? A cube. What is the volume of the imaginary sphere? 1/6 pi dp cube. Okay. From this you get some value for dp. dp is nothing but A into cube root of 6 divided by pi. See, now you have all the things in your hand to compute. You have volume of the particle, surface area of the particle, and dp is the imaginary sphere diameter. Okay. Then once you have all the things, substitute in this equation. Substitute 2, 3 and 4 in equation 1. You get the sphericity of this particular cube, 6 by A times cube root 6 by pi into A cube by 6A square. Finally, if you calculate, you get the sphericity of cube is 0.81. What this means? That means the shape of this cube when compared to that of a sphere, only 81% matching. That means the shape looks like a sphere only up to 81%. That's what the take away from this example. Similarly, you can calculate the sphericity of a rectangle, sphericity of a triangle, similar way. So pictorially, what is this? What we have just calculated, the sphericity of the cube means surface to volume ratio of this particular sphere, particle, I have to do the other way. Surface to volume ratio of this particular sphere divided by surface to volume ratio of a sphere. Thank you. And okay, sorry, I am correct. Okay, it is the right way. Always you have to compare with of a sphere, right? This is the right representation. Always you are comparing, right, as per definition, how much it is close to the sphere, how much it is not close to sphere. Always we are taking these two ratios. Similarly, as a homework, please do, compute, take any rectangle of a different size and compute the shape. Take a triangle of a separate shape, compute, to calculate sphericity of that particular different shapes, because this sphericity get into the many definitions. Like if I have to find out the surface area of the particles, then I have to use the sphericity value. If I have to calculate the how many particles is there in my mixture, and sphericity will find a role in there. So this, the sphericity as such, you have understood, hope, and let us see. Thank you, and see you soon with the next possible lecture.